There are a set of facts known as 5 and facts, which use the number 5 as a quicker way to figure out the answer to certain problems. We'll explore this with both addition and subtraction in this video. We'll use visuals for 5 and with finger patterns, on a domino, and on a tens frame. It's useful to use the visuals for two reasons. You may find that you need them to start off with to help you solve the problems. But they're also useful because you may find that you start to picture these images in your mind, and you can use these to help you think about ways to solve more challenging problems in the future. In this video, we'll try and record both addition and subtraction equations that relate to these 5 and facts. We'll try to think of more than one way to write these, including with the equal sign in different positions. If you're having difficulty making sense of the equal sign being in a different position, you may find it useful to review the video on the equal sign first. Pause the video and try to think for yourself of some equations that might match this image, and for this video, try to use the 5 as part of your equation. You might have thought of 5 plus 3 equals 8, seeing the 5 black dots on the top and the 3 red dots on the bottom, and therefore 8 dots altogether. You might have thought of 3 plus 5 equals 8, seeing the 3 red dots on the bottom, the 5 black dots on the top, and therefore 8 dots altogether. With the equal sign in a different position, you might have thought of 8 equals 5 plus 3. So seeing that 8 is made up from, or composed from, 5 black dots on the top and 3 red dots on the bottom. Or you might have thought of 8 equals 3 plus 5. So seeing that 8 is made up from, or composed from, 3 red dots on the bottom and 5 black dots on the top. What if we had the same image, but we were trying to think of some subtraction equations to match the image? Again, trying to use the 5 and facts as part of our equations, and again with the equal sign in different positions. Pause the video and try and think of some equations that would fit this. You might have thought of 8 minus 5 equals 3, seeing that there were 8 dots altogether, and visualising the removal or subtraction of the 5 black dots on the top, leaving the 3 red dots on the bottom. You might have thought of 8 minus 3 equals 5, seeing that there were 8 dots altogether, and visualising the removal or subtraction of the 3 red dots on the bottom, leaving the 5 black dots on the top. With the equal sign in a different position, you might have thought of 3 equals 8 minus 5. You may have visualised how you could leave just 3 dots from the image you started with. So 3 has the same value as 8 minus 5, because if I remove the 5 black dots from the 8 I started with, I'm left with just 3 red dots. Or you might have thought of 5 equals 8 minus 3. You may have visualised how you could have just 5 dots from the image you started with. So 5 has the same value as 8 minus 3, because if I remove the 3 red dots from the 8 I started with, I'm left with just 5 black dots. Let's have a go at a few more. After each question, pause the video to try to work out the equations that match the image. In this video, we'll continue to use 5 as part of our equation. What numerals go in the boxes to make this equation true? You might have thought of 10 minus 5 equals 5 by visualising the 10 fingers you can see to start with, and imagining removing 5 of them, which would leave just 5 fingers. What numerals go in the boxes to make these equations true? You might have thought of 0 plus 5 equals 5, visualising the fact that there were 0 dots on the left and 5 dots on the right, giving a total of 5 dots altogether. Or you might have thought of 5 plus 0 equals 5, visualising the 5 dots on the right first and then 0 dots on the left, but still giving a total of 5 dots altogether. What numerals go in the boxes to make these equations true? You might have thought of 9 equals 5 plus 4, visualising the 5 fingers on the left first and then the 4 fingers on the right. Or you might have thought of 9 equals 4 plus 5, visualising the 4 fingers on the right first and then the 5 fingers on the left. What numerals go in the boxes to make these equations true? You might have thought of 5 equals 9 minus 4, visualising 5 dots being left after subtracting 4 dots from 9 dots. So 5 has the same value as starting with 9 dots and subtracting the 4 red dots. You might have thought of 4 equals 9 minus 5, visualising 4 dots being left after subtracting 5 dots from 9 dots. So 4 has the same value as starting with 9 dots and subtracting the 5 black dots. What numerals go in the boxes to make these equations true? You might have thought of 7 minus 2 equals 5, visualising the 7 dots that you started with and subtracting 2 red ones at the top, leaving just the 5 black ones on the bottom. Or you might have thought of 7 minus 5 equals 2, visualising the 7 dots that you started with and subtracting the 5 black ones at the bottom, leaving just the 2 red ones on the top. Hopefully that's given you some ideas about how the number 5 can be a useful number to help you think about the ways that numbers between 5 and 10 are made up. You've also explored how to write different addition and subtraction equations using the number 5 as part of this.